We're now going to take a look at some formulas that you can use to do derivatives. And the key is that we're only touching on a couple. We're going to be touching on some transcendental formulas which deal with logarithms and exponential functions. There are a whole set of rules or shortcuts for finding the derivative of trigonometric functions or trig functions. And if you were taking the 5-credit calculus for engineers and that type of major, you would be using the trig rules as well. So we are specifically looking at exponents and logs. If at this point you are uncomfortable with finding the log or the dealing with exponential functions, I encourage you to take a pause from this video and go review logs and exponential functions. There are some videos in Blackboard under tips and tutorials that will help you reintroduce yourself to what a log or an exponential is. But we're going to hit the basic rules, and as I've mentioned in videos before, there are many rules. There's a book of rules, and so if you needed to take the derivative of something you didn't have a basic shortcut to use, you would go look up the formula in a book by matching your function to the functions that are listed there in general. So let's get going on exponential functions. Remember that an exponential function is something like 2 to the x, where we have a base that is a number and your independent variable is in the exponent. So to take the derivative of any of those functions, you use the formula. It is the ln, remember ln is natural log, the ln of a times the original function a to the x. Now, the formula for y equals e to the x is technically, I'm going to kind of work in the middle here. Let's follow the formula we just wrote for any. So this one here is for any base. So let's follow that for base e. So on this example or this function we have base e. So that would tell us that the ln of e times e to the x. But the natural log of e, and if you put it in your calculator and hit ln e, you'll get the answer. But also what that is saying is e to what power gives you e, and the answer is 1. So this is just really 1 e to the x. So the derivative of e to the x is simply e to the x. You technically don't have to remember that as long as you know this formula. That is really the only formula you need for exponential rules. If in your power is an actual function, like in the third item here, then we have to follow the chain rule. So first we would take the derivative of the original function, so that's that, but then you're going to have to take the derivative of what's up here. Because technically we do that in the original one, but the derivative of just x is 1, and so that's why we don't write that. So let's use these to do the following examples. The first example, y equals 5 to the x, has a base of 5, so our a equals 5, and we just have our x up in the power. So we're going to use the highlighted formula and do the ln of a. So we're going to do ln of 5 times 5 to the x, the original function. And technically we take the derivative of x, which is just 1. Now if your answer has to be exact, then this is your answer. If they ask for a decimal approximation, then you could take the ln of 5 in your calculator, but you cannot multiply that times the base 5 because that 5 has an exponent. So this is really your final answer. The next one, the derivative of e to the x, as we noted, is simply itself e to the x. The third example, there is now more stuff up in the power. So here's what we really have using our blue and red concept from before. We have 4 to some power, but that power is more than just an x. So we're going to have to take the derivative of the blue times the derivative of the red. So first, let's take the derivative of the blue. The derivative of the blue is following the exponential, which is the yellow highlighted. So we're going to have the ln of 4 times our original function. Okay, so that's taking care of the blue. Now we need to take the derivative of that little function in red, so the derivative of that is 2. So our final answer is 2 ln 4 times 4 to the 2x plus 3. So when your power has more stuff in it, you have to remember to take that derivative of that power. And even when your power doesn't have more stuff, if you take the derivative of just x, if we did that back on the first example, the derivative of just x would just be 1. And so technically we could do that method all of the time. So those are exponential rules. You might want to refresh yourself and look at the graph of the exponential and think about its slope, and then graph the derivative and see that that says the same information. Now let's talk about logs. Remember that logs are something like log base 7 of x. So that's asking 7 to what power gives me that value of x. So the basic log rule looks like this. 1 over ln of a times x. X being the value there. Again, if there was a function there, we would simply say it's 1 over the ln of a times that function, whatever that function is. So here we just had an x, but here we have a g of x. We have a big function there. Now the reason we have those absolute values there are because you cannot take the log of a negative number because it's an osculating function. And I think if you remember back when we were talking about limits, I talked about there are some functions that are osculating, and that's a good example because when you have when you're trying to take things to a power to get a negative result, that only works in some cases. Now back to this formula. When you have a whole function in there, you have to remember to multiply it by the derivative of the function. And for the same reasons that the derivative of e to the x is e to the x, we could again go through the formula. So in this case, remember this is base e, so this would be 1 over the ln of e times x, and the ln of e is 1. So this would be 1 over x. Alright, so let's use that. First of all, just y equals log of x. And you need to know what base this is. And since there's no base given, it's a common log, which is base 10. So the derivative would be 1 over the ln of 10 times x. It is important that you don't say the ln of 10x. It's the ln of 10 times x. The next one is a ln, but we also have some stuff inside of here. So we are going to have to use that chain rule to make sure we have the derivative. So here's what we have. We have the ln of 8 minus 3x. So in the end, we have to take the derivative of that. So to find the derivative of this, you can use really any of these formulas to help you here. If you want to use the second one, that it's equal to 1 over x, that's fine, but let's walk through. So we do 1 over the ln of the base, and base is ln e, so 1 over ln e times times the original function. Then we have to multiply that by the derivative of the red, which would be -3. And so our final answer would be -3 over 8 minus 3x, because the ln of e is 1, and 1 times -3 up top is also -3. Okay, so it's important for you to understand that the ln of e is 1. And again, go back and review those tutorials if that's sketchy for you. Alright, so here we have a log, and because there's no base, it's base 10, but we're taking the log of something. So we have to do the chain rule. So our derivative is, first we do the log, which is 1 over the ln of 10 times the function, and then we do times the derivative of the function, which is 4. So our final answer is 4 over ln 10 of 4x minus 1. So remember, in the end, you have to have taken the derivative of everything. And so the chain rule is used a lot in the formulas. So truly, if you understand the chain rule, then you need those two yellow formulas. If you know those two formulas and you understand the chain rule, then you can put those two together to take the log or exponential derivatives. So now what will be important is for you to practice all these types of derivatives, and then in our next section we'll be looking at how we do a little more complicated type of work. So good luck practicing.